Hello, everyone. As we haven't met before, I'm Joel Morgan. I'm a senior solutions architect at Amazon Web Services. I cover the University of Washington. I'm a technical resource for customers. So email me, ask me stuff. Do everything from answering questions to helping design big architectures and migrations of new applications. So today I'm going to talk about, we have a very, very large, like, how many people, like 40 to 60,000 people in November, late November, go to this big conference called ReInvent, where we have a lot of new releases and updates and such. So this session will be going over things announced at ReInvent. Many of them have been released, some of them have not been released. Almost all of this is probably public, but I do have to say that this is under NDA. Non-disclosure agreement. We have a mutual NDA with the University of Washington. So I'm happy to provide these slides after the presentation. This is being recorded, so people can watch later if they can't be here or can't stay for the whole thing. But note, do not repost any of this stuff. If you see something in here that's very interesting that you would like to send to a colleague outside of the university, look it up. It's probably been publicly released now because it's already February 1st. But I got to put that in front just in case. Without further ado, I am going to be probably speaking very rapidly. I am not an expert in everything because this is drinking from a fire hose. Everything that I'm going to talk about here has been condensed, like it says, 1,000 hours in 60 minutes. That being said, if you have a question or you want more information about something, please contact me or Jeff, the account manager, and we will follow up with you about it. So without further ado, remote is not working. Okay, first we're going to start with compute. So we have many different compute options in AWS. You've probably at least heard of EC2, but we're going to go over some deep stuff here. Research and Engineering Studio on AWS. So it is an open source, easy to use web-based portal for administrators to create and manage secure cloud-based research and engineering environments. So we have many millions of people doing research on AWS. But Research and Engineering Studio is a new offering we have that makes it easier to spin up a research environment and provide not only that, but provide access to people in your lab, your PI, your lab manager, or your working with other institutions or other groups. RES is an easy way to get people access to those resources. Okay, quick reminder on EC2 naming, because it looks like you just shook up a bunch of letters in a bag and dumped them out, but this is what it means. EC2, Elastic Cloud Compute, which these are our kind of standard virtual machines. We have many, many different types, instance types, and this is the taxonomy of how to understand it. So like we have instance family, generation, processor family, and then the additional special stuff. This is just a reminder. These are some of our new things. R8G instances with Graviton, Graviton 4. Very quickly, Graviton is an ARM-based processor as opposed to an x86 style processor. Amazon makes these. We design and manufacture the Graviton processors ourselves. The price performance ratio on them is frankly amazing compared to an x86 processor from Intel or AMD. So while not technically super faster than the x86 because they are different architectures, they are the performance you get for the price is really quite impressive. So R7, 8, so 3 times more virtual CPU memory than the R7G. If you're using the R family are for high memory instances. So if you're running an in-memory database where you need something with like terabytes of RAM, look at the R series.
Is it common knowledge how Who produces Graviton? Is there a company to point to?
Us.
AWS is
AWS.
in the chip design and manufacturing business.
Many years ago, it's been about 7 or 8 years. We bought a company that was making high performance ARM chips.
Okay.
We then integrated them into AWS, and since then they've been making the Graviton chips.
Okay, thanks.
Yeah, so if you compile your software for ARM, then look at Graviton. U7I instances. So ultra low latency databases. So like 16, 24, 32 terabytes of RAM. So if you need something to be memory resident, like not written to disk, you want the absolute most bonkers, ridiculous, fast access to it. This is something you can do. Honestly, this is more for like running SAP HANA or something other than research. But if you have an in-memory database that you need to run with 32 terabytes of RAM, then this is for you. Trainium, our Trainium 2, this is our second generation of our Trainium chips. Trainium instances are an ASIC, an application-specific integrated circuit for training, ML training, AI training, as opposed to using a GPU, which are expensive. If you're training a model, you can use the Trainium, an EC2 instance with a Trainium chip that's 65 exaflops of supercomputing performance instead. So 4 times faster than the previous generation, can be deployed in EC2 ultra clusters up to 100,000 chips, training large models in a fraction of the time while improving energy efficiency 2 times.
Do you know like which libraries work on top of this? Like PyTorch, TensorFlow, stuff.
Yes, both of those. I don't know the full list off the top of my head, but the most common stuff. Yeah, so PyTorch and TensorFlow for sure.
I would imagine it's not CUDA compatible per se, but it's something else.
Right. Yeah, there is a different API. Yeah. They're pretty impressive. I gotta say, because and way less expensive than the GPUs. So GPUs are fantastic, and we have way more available than you can go buy in a store. But if you can code to this will be a lot less expensive.
Sorry, this may be unanswerable, but is the idea that this is something that's so new that it's not being uptaken at capacity that people do what they're used to? So they stick with the GPUs even though this is new?
Yeah, mostly from what I've seen, it's I either have code that I can't change because it's commercial software, someone else wrote it, and I can't modify it, or I don't have the expertise, or I don't want to for whatever reason. And this is, you are using like PyTorch or TensorFlow, but getting it to run on one of these chips does require some effort for proprietary. So if you wanted to keep it pure CUDA so that you could run on any NVIDIA chip anywhere, then you would have to go with the GPU instance. But if you wanted super fast performance at lower price and higher availability, then this is.
I have a question. How does Trainium compare to that U7, the one from 2 slides ago?
These are just generic EC2 instances with basically a ridiculous amount of RAM. That's oversimplifying it. There's been other lots of other improvements, but this is really just a processor. Normal x86. This is something that's added in addition to the CPU of an EC2 instance that's specifically built. Like this is hardware designed just for training an AI or ML. It's not a general CPU.
So one is a CPU version, the other this GPU replacement.
This is the GPU replacement.
Alternative.
Yeah, because the GPU can do many different things. In fact, it wasn't originally built for training models. But this is you can only do that. You cannot display things on it. You cannot do 3D rendering or anything like that.
Got it.
We don't have a new generation of it, but we do have an inference chip too, inferentia. So the other part of using machine learning. So hardware, and so it's hardware in addition to the CPU that can do inference. And I just see this. Okay.
You can try clicking the blue OK button, might go away.
Oh, I could not see that it said okay.
It's, yeah, sorry, the furthest right. Yeah, there.
Ah. So this is our Amazon Time Sync service. So anyone with fine time requirements, or users of Aurora Unlimited, clocks can be accurate to billionths of a second anywhere in the world. Can be used to more easily order application events, measure one-way network latency, and increase distributed application transaction speeds. I don't know if anyone will care about this, but I thought it would be, so I'm putting it here. So we have like dedicated specialized hardware just for accurate time.
Can I ask a nerd question?
Please.
What is the reference clock? Like what technology is the reference clock using for timekeeping?
That is a good question. I will have to follow up on that. I assume it's an atomic clock, but I don't know.
Cool.
Not specifically, or I don't know which one.
Yeah.
Yeah. We just bought a whole bunch of cesium, it's just sitting in.
Turns out.
Decay and. No, is it being recorded? No, we do not have a.
Yeah.
Please. Lambda scaling improvements. So, new underlying infrastructure improvements are now available, for all synchronously invoked Lambda functions at no additional cost. The rate of scaling availability has increased to 1,000 additional concurrent executions every 10 seconds. So these can scale at this rate up to your account concurrency limit. So Lambda previously scaled concurrent execution at the account level up to 3,000 concurrent executions in the first minute, followed by 500 concurrent executions every minute afterwards, up to the total account concurrency limit. So this was shared across all functions in the account, meaning there could be a delay in scaling concurrent executions for one function due to recent scaling for other functions. So now Lambda can scale much more rapidly every 10 seconds, and each function scale is evaluated independently. This allows your serverless applications to absorb traffic fluctuations without affecting the scaling rate of any other function in your account. So earlier this year, we also increased scaling rates for Lambdas that pull SQS queues and Kafka topics as well.
Do you know of any recent increases to the size of the Lambda?
Size.
So usually there's a limit to like how big your package can be, like if it's a Python chunk, right, of packages. We keep that limitation in the past.
I'm not sure if, like, there isn't in this deck, but I don't know off the top of my head the last time that was bumped up. They're bumped up periodically. What are you looking for? Like, what's your magic size?
I don't remember the number,
Yeah.
but this was like, I don't know, 4 months ago maybe, where
Okay.
we were hitting some limitation.
Oh,
I was
okay.
just curious if there's any recent things in that respect.
I mean, I don't know, there could have been, but I'll. Yeah. And apologies if I'm reading this, I couldn't memorize the notes for all,
Yeah, no, it's-
thousands of these, so I will be reading most of these. Anyone who works with EKS, which is our Elastic Kubernetes service, knows they can be complicated to grant your EKS pods the permissions they need to access AWS resources, because you switch between Kubernetes identities and IAM, identity and access management permissions. So with the EKS pod identity agent for EKS, you're able to control an IAM role with the pod's service principal in the trust policies, and then map that role directly to a Kubernetes service. So simpler workflow for authenticating applications to AWS. EKS pod identities provide the ability to manage credentials for your application, similar to the way that Amazon EC2 instance profile provide credentials to Amazon EC2 instances. So instead of creating and distributing your AWS credentials to containers or using an Amazon EC2 instances role, you associate an IAM role with a Kubernetes service account and configure your pods to use the service account. So Amazon EKS pod identity supports Kubernetes running version 1.24 and above in EKS. So Amazon Backup, EBS Snapshot, Archive support. So with EC2 instances, the storage component, the EC2 is called EBS, Elastic Block Store. Since its inception, you have been able to take snapshots of them. They are incremental. They are, I mean, you don't have to think or worry about it. They are stored S3 on the back end. Now you can archive those because before you could take as many as you want, keep them as long as you want, but they were charged at pretty much the S3 rate, right? With this, you can now archive EBS snapshots. So if you are regulated to keep something, or you just simply want to keep an EBS snapshot for a long time, it's now less expensive. This I didn't have. Okay, so that was compute. Now on to database and analytics. So Amazon Aurora Limitless Database. Amazon Aurora is our database system, if you will. There are Postgres and MySQL engine compatibilities. So for customers with massive database transaction requirements, nearing millions of transactions per second, you can overwhelm the capacity that a single Aurora writer endpoint can provide. Instead of managing your own shard splits and merges, you can use Aurora Limitless databases. It will manage transactional consistency across separate database shards and provide horizontal scaling for your write throughput while maintaining transactional consistency across all shards, all from a single shard group endpoint. Yeah.
Could you just briefly talk about the trade-offs between using something like Aurora and using RDS, like a traditional thing? Like, is Aurora more expensive than RDS? Is it a different use case entirely?
Yes. So RDS, a relational database service, is basically we're hosting a database engine for you.
Right.
Postgres, MySQL, Oracle, Microsoft, right? But really, we're just abstracting away the carried feeding of the database service. With Aurora, we have a little more, like we have recompiled the database engine for our infrastructure, and we're using a customized storage system. So rather than just hosting something and optimizing what we can from the outside, this is Aurora's purpose-built to run on AWS infrastructure. Now, trade-offs. So Aurora has things like different types of scaling. It has serverless. This is serverless. So there's lots of advantages. Disadvantages would be could be cost. You may be able to get away with a cheaper RDS or even cheaper just running on EC2 depending on the use case. And not because of any like, oh, I work here or anything, but there's really very little compelling reasons to go with RDS over Aurora. If you're using a non-commercial database, if you're using Oracle, you're using Microsoft, you have to use RDS because you can't. If you're using something Postgres, and maybe you're locked to a very, very specific version, or maybe there's just something really bizarre about the way your database is set up, there is a chance that it won't work with Aurora, but it's these days very unlikely. So Postgres, MySQL, look at Aurora first.
Cool.
Yeah.
Can you explain what's the role of the orchestration with this type of serverless infrastructure? Like, is this supposed to optimize queries, or is it no?
You know, what this is really doing is optimizing scaling and optimizing the storage component. Because in RDS, if you have two RDS instances, they have to basically sync with each other, right? Because you can't have two databases that you can't read and write to two different databases unless there's some kind of replication. Aurora gets around that because they do have a shared source. We're able to do that. We modify the database to do that. This specifically limitless database, this is for like ridiculous scale writes, where you're doing just a huge numbers of writes, and this will scale to meet that without having to shard your database. So it's kind of handling the sharding for you. So sharding is where you take a piece of your database that All right, well, this data is all related somehow, but not related enough that I should keep it on the same database server. So queries for this goes to a different database server. It's all part of the same schema. That's what sharding is. Like, all right, this is all part of the same schema, but this part, like, never really interacts with this part when making a query. So I'm gonna put this on a different database server to scale out performance. This is kind of doing that before. Yeah, I'll be blunt, academic and research, probably aren't gonna get much use out of this. This is for,
Transactions.
yeah. Yeah, huge transactions. Right transactions, like reads, yeah, you need high speed reads for sure when you're doing data science, but this is more for. So Elasticache, so we now provide another serverless offering for Elasticache, so that guessing about sizes and managing cache capacity. You can launch a highly available cache without sizing specifications in under a minute. So as an application's working set grows, Elasticache serverless removes the undifferentiated heavy lifting of sizing and managing cache capacity, ensuring that your cache performs when you need it. So it's PCI DSS, SOC, and HIPAA compliance eligible. So if you use Elasticache serverless for Memcached, there are significant benefits of high availability and instant scaling because they're not natively available in the Memcached engine. You no longer have to write custom business logic, manage multiple caches, or use third-party proxy layers to replicate data to get high availability of Memcached. Supports Redis 7.1, Memcached 1.6.22, and above in all commercial regions. So up to 5 terabytes memory capacity.
So if I'm a Redis user, this is basically like a AWS optimized version of Redis, basically.
Yeah, and so then you don't have to like set up an EC2 instance, install Redis, all that stuff. It's just like, hey, Elasticache, I want a Redis cache. Go. And before you would still have to specify some like sizes with serverless, you know, it's like I want Redis, I want that cache. Any IBM DB2 users out there? Yeah, good thing, but yeah, that was the slide in. Because this is, well, maybe not super relevant for this audience, is actually a really big deal. So RDS, or like database service, you can host, you know, all the ones I mentioned before, the commercial ones, or Microsoft SQL Server, Oracle, and then of course MySQL, Postgres, Maria. But now IBM DB2 on RDS, so you can say, I want a DB2 database, and you didn't have to spin up any servers, you don't have to do any like admin stuff, it's just there, ready to go, import your data. I won't read the whole slide there, because, well, big deal, like I said, I don't think anyone on the call or in the room are using it. Unless there's a mainframe on this floor that I have not seen, if you do have one, I would love to see it. Cool. Vector database support on AWS, so so you can't simply hook databases into advanced ML models. Many of the machine learning models that build conversational chatbots and contextually aware response and recommendation tools that we see today require data to be encoded and stored, so it can be searched based on logical relationships and meanings. So databases that were traditionally providing search based on character sequences often don't support these vector embeddings. AWS had already announced that OpenSearch, Neptune, RDS Postgres, and Aurora Postgres support. So now customers have vector support for MemoryDB and DocumentDB, and they can leverage zero ETL integration from DynamoDB to OpenSearch for vector support. Even further, Amazon Bedrock now supports direct integration of Vector Engine for OpenSearch Serverless, Redis Enterprise Cloud, and Pinecone, with Aurora and MongoDB vector database direct integration coming soon.
Is it correct to say that this is a database or a database option, but it's meant for generative AI specifically?
in my admittedly limited knowledge of using vectors in databases, this is an outfit of support for that methodology in these specific, yes.
Okay.
So would it be fair, is my understanding accurate to say that what this is saying is if you want to train a machine learning model on a large corpus of data in a database, then rather than loading all of that data out of the database into, say, Python and arranging it into an array properly so that it's all vectorized and ready to train, you can, through some magic, train your algorithms directly on data in the database without having to load it separately in like a Python script.
I don't think that's the use case. So in general, in a database, the traditional database search, where you're gonna take a word and then it's gonna be indexed into some way, right, to find the row that has that word. Vectors basically use a machine learning model that maps some arbitrary piece of text into a vector of fixed length. So let's say 128 floats, right? So now that vector is a representation of the meaning of that piece of text. So vector databases allow you to find content based on these representations that were learned. Right? It's kind of a semantic way of learning, and they're used a lot for LLMs because LLMs want to like fetch some piece of content based on some query and then use the LLM to process the result.
I see, thank you.
Hey. Know way more about it. I'll deal with it. So vector engine for Amazon OpenSearch serverless. So we have OpenSearch, hosted OpenSearch. This is, as you can see, vector engine support for OpenSearch. It's very much built on Flask. One more on the subject, vector search for Amazon Document DB. So with Document DB, you can extend your existing document database model with a simple scalable vector search functionality for semantic search on your document data, unlocking a wide range of use cases, including semantic search, product recommendations, personalization, and chatbots. White eraser. Love eraser. And then more vector stuff. So vector search for Amazon MemoryDB Redis. So with MemoryDB, you can store millions of vector embeddings and perform tens of thousands of queries per second at greater than 99% recall with single-digit millisecond vector search and update rates. So MemoryDB is one of the fastest vector search experiences on AWS for applications that require high throughput and high recall with single-digit millisecond query and update response times for tens of thousands of queries per second.
Is MemoryDB a database on top of Redis? Or what is MemoryDB? So,
it is MemoryDB for Redis. It's on top of Redis. Yeah.
I'm trying to think through this. Is this built for a particular language? Like English only, or is it really flexible to any language?
it depends on the model that you're using for embedding. A lot of the newer models are multilingual. That's very common use case. But yeah, depends on the model that you're using for embedding. I think the capabilities of these databases are to take, and I don't know if arbitrary, but they can tell different sets of embeddings, and then just being able to basically convert your entire database into each document into an embedding that you can store. Now that's your index. And then any query, you convert it again to the same embedding. And now you're doing a vector similarity search of your query against your database. Right? And that's where they say below that you can do a Euclidean distance, a cosine type of similarity. So it's a way of semantically searching your data or an embedding model.
It's like document level search.
It's document level search, correct?
Thanks.
So next is Amazon Redshift serverless AI scaling. So Redshift serverless already automatically provisions and scales capacity to meet demand based on concurrent queries. But now with your input on these trade-off preferences, AI scaling can be configured to optimize your workload to scale based on query complexity, frequency, data size, and more. And it will continuously adjust across the workload. So, Redshift serverless automatically provisions and scales data warehouse capacity to meet demand based on the number of concurrent queries. With the new AI-driven scaling and optimizations, Amazon Redshift serverless automatically scales resources up and down across multiple workload dimensions and performs optimizations to meet price performance targets. So Amazon Redshift serverless uses AI to learn customer workload patterns along dimensions such as query complexity, data size, and frequency, and continuously adjust capacity based on those dynamic patterns to meet customer specified price performance targets. If you ever scale Redshift, basically this long story short, this is going to let you scale it smart. Redshift performance enhancements. So you can now use create table as select operations with seamless scale or provision cluster concurrency scaling or serverless auto scaling. You'll be able to write multiple Redshift databases simultaneously across account or region. Multi-dimensional layouts is a table sorting mechanism that uses Redshift automatic table optimization to improve performance of repetitive queries, with some internal testing showing a 74% runtime reduction. Also, incremental refresh eliminates the need for full refreshes when you're loading materialized views stored in S3, reducing time and cost to refresh materialized views with large tables. Question?
I am sorry to be dominating the questions.
That's okay.
So my understanding with AWS Redshift is that it is a serverless query towards S3 buckets, right?
Yes.
So all objects inside an S3 bucket is represented like a database?
Well, so Redshift has different ways of doing it. If you can do it direct S3, you can load it into Redshift's data warehouse. So it's either ingesting into a Redshift data warehouse where it spins up the compute and storage that's needed to do your queries, to do your analysis, or you can point Redshift, like Redshift Spectrum at S3. This is different than a service that we have called Athena, which is querying data in S3 objects directly.
Oh, okay.
Yeah, because Redshift has a schema, it's a columnar data warehouse style.
So why would what is the performance enhancement here? Is it for the conversion of S3 to the data warehouse?
No, it's the data warehouse itself. It's scaling. You provision a cluster, and you can scale ETL, like I said, scale ETL and other write workloads. Scaling right is always a problem with any database, right? We're doing things to try to make that easier across all of our databases.
Once an S3 data lake is converted into a Redshift data warehouse, does it stay there in perpetuity? Or sorry, is it an object in itself? And then you could then query that object?
It could be. So you can point Redshift, which will spin up the compute engine it needs to query S3. Redshift is typically meant to go away unless you have the need and to be upfront, the funding to have a persistent data warehouse. Now, compared to traditional data warehouses from other companies, which were 6, sometimes 7 figures, a year to even purchase, Redshift is a big deal. But we've made it easy so you can spin it up to do what you need to do and then turn it down. If that means with a traditional Redshift, where, okay, well, I have sucked in data from S3, from other databases, from other data sources into the data warehouse. I've done my analysis, run my reports, saved that off somewhere else. All the data is somewhere else originally, so I can throw the whole thing away. But what I think you might be asking is, if you point this at S3, it's not going to alter the objects. Any results from queries you have to save somewhere, whether that's S3 or not, sure.
Okay.
Yeah.
Thanks.
Zero ETL integration with Amazon Redshift. You have the ability to move data between purpose-built transactional and analytics data stores across your environment without data engineers building and maintaining ETL pipelines. So just like AppFlow gives you a codeless integration of sources externally to store and operationalize data, now databases within AWS are being integrated. So we already announced the general availability of Aurora MySQL to Amazon Redshift. Now available in preview, you can use zero ETL integration between Redshift and Aurora Postgres SQL, RDS MySQL, and DynamoDB. Basically, it handles some ETL for you when going between some of these different services, as opposed to having to go into Glue or something.
Okay.
So very much the same thing, zero ETL integrations with Amazon OpenSearch. Zero ETL integrations are available for DynamoDB to OpenSearch and S3 to OpenSearch. So easily import operational data into OpenSearch for full function search capabilities. Custom data mapping for full control over OpenSearch index format. No additional costs except underlining DynamoDB stream and OpenSearch compute unit for integration for ingestion. DynamoDB zero ETL with OpenSearch is generally available in all AWS regions where OpenSearch ingestion is available. Amazon Neptune. So this is Neptune is our graph database. So performing advanced analytics on graph databases can be done natively using Amazon Neptune and Neptune Analytics. You can now call these common algorithms against billions of graph connections in seconds, delivering insight 80 times faster than existing solutions. So Neptune Analytics enables quick loading large data sets from Neptune or S3 data lakes and running analysis of billions of graph connections in seconds using 4 families of common graph algorithms with up to 80 times faster insights than existing solutions. That has a big list of algorithms, pathfinding algorithms, breadth first search, single source shortest path, neutrality algorithms, similarity algorithms, and then clustering or community detection algorithms. That's a big list. AWS Glue data quality anomaly detection and dynamic rules. So Glue is our ETL, our serverless ETL engine. So Glue data quality will already generate static quality rules for your data, but attempting to codify static rules for anomalies and unexpected patterns is nearly impossible. So Glue data quality anomaly detection and dynamic rules generates adaptive and dynamic rules using machine learning powered algorithms to allow you to spend less time constantly tinkering with rules and more insight in your data. So Glue data catalog, multi-engine views. So today when customers create a view that needs to be accessed from multiple SQL engines, they need to create separate views for each engine and access needs to be granted to each view and underlying tables. Using Glue data catalog views, customers can create a single view object that can be queried from multiple engines without having access to base tables of the view. Administrators can use multi-engine views to control what parts of the underlying data consumers can access using the rich SQL dialects provided by SQL. Access to views can be controlled by the same lake formation permissions, resources, columns, and tags used to grant access to other resources and data. So using a single view reduces the risk of inconsistent permission application. So anyone using Glue here? I agree.
Can you clarify? So Glue data catalog is basically a series of stored procedures querying these databases?
Yeah, kind of. And Glue data catalog knows what's in there. So Glue is a database, but it knows what the schema is of these databases and how to extract data from.
So what's the role of the view?
The view is if you're using Glue, you have your data in a database, you're using Glue interface with the database for ETL. If you have multiple, like here we have Athena and Redshift and EMR, those are different services, and they can all use the same Glue data catalog that's catalog what's in your database down here. But the way they do it is different. So it is all SQL, but as you know, SQL is not all the same between different engines. So if you're using Athena, this is the view. If you're using Redshift, this is the view. EMR, this. And you can set permissions on it too. For each view. Set permissions on Glue, the data catalog as a whole.
To think about it.
Yeah.
It's like, are you, for this data catalog to work, would you be querying Athena to a table? Or in this case, you're querying a view?
So it's Athena can see this. So rather than like Redshift, querying another database directly, you're going through Glue to do it. Well, Redshift can only see X, Y, and Z when it's running query. Because that's the Redshift view.
Wow.
So if you have duplicate views or you want one view, say, okay, I don't care what tool you use, but you all look at it the same way, you can do that. Okay, EFS archiving storage class. EFS is our last file system. It is a serverless NFS. Sorry.
Yeah, it's water.
No, yeah. It is a serverless NFS file system that it's been around for a long time. You just say, I want a file system. You don't have to specify size. It gives you mount points. You're done, right? It will. You only pay for what you use. Kind of like S3, but this is a file system. Well, we started with EFS standard. Then we moved on to infrequent access. So these are, and this is using S3 terminology, but this is the EFS. Say, all right, well, I have things that need to be in a file system, but I probably won't touch them very often. So we said, okay, these files can go in infrequent access and you pay less for that data. Well, now we have archive stuff. So archive is like, all right, I have this data. It has to be in a file system. I cannot offload it to a traditional archive. I can't put it in Glacier Deep Archive. I can't put it in some sort of cold storage. If I need it right away. And I need it as a file system. Can't run it through a backup application. It's got to be, I double click on it in a file explorer, that kind of thing. That's what EFS archive storage files. Yes.
I happen to know that Glacier Deep is 1/10 of a penny per gigabyte per month.
Yes.
What is this?
This is
You're asking about EFS archive.
yes. It is not that inexpensive.
I figured out this is just a ratio.
Yes, I would have to look it up.
Okay, never mind, I can look it up.
Is the request charge is, okay, that's just funny. Yeah, I should have looked that up. Baseline storage costs 50% lower. I don't know,
Okay, so let's not worry about it.
because it's just. But it is significantly less expensive. Yes. It will not be as inexpensive as the GPA. And the F3 access grants. So access grants, so basically this lets you use an external identity to give permissions and access to data in S3. So if you work with S3, you know that there are very robust permissions, but it is all based on S3 and IAM, right? You have a bucket policy, you have an IAM policy, you can have S3 access points. But with access grants, you can now use an external identity to grant access to things in S3. For example, something like Okta or really Active Directory is a big one. You can say people in this Active Directory group can get access to this bucket or objects in this bucket with this prefix. And in S3, it's not a file system, it's an object store. That's how you separate data, is by prefix. It looks like folders. But access grant is a way to grant. It says grant access using an external identity instead of writing bucket policies and IAM. I was really excited. I knew about this one in June. It wasn't released till then. This is not really an announcement, but this is part of the deck and I really liked it. So I wanted to show, this is latency for our storage services. And this is kind of average latency, it can be much lower. Okay, not much lower. That'd be ridiculous. But I really like this slide. I'm glad it was included in this deck. This gives me an excuse to talk about it. Yes. So we have Glacier Deep Archive, which is 12, 48 hours to get your data back, versus Instant Store, which is around 100 to 200.
Is this like on a web page somewhere?
It is not.
That would be super cool to have. Useful.
EBSGP is general purpose.
Yes. Yeah, general purpose versus the IAM.
Okay, so the basic fast S3 is 10 milliseconds versus 1 millisecond per G.
Yes.
So, got it.
Yes. Yeah, and IO2 is really for if you have a workload that has a lot of sequential read and writes. You're doing, Spark, Hive, stuff like that, or something. Yeah. And kind of one thing I will point out is like when you get to here, this is no longer file storage. This is object storage, right? So keep that in mind. Most of the time when you're talking, when you're talking to these three, you're talking directly from an EC2 instance, directly to those. You can't separate them. These are network file systems. So you're talking from an EC2 instance or possibly an on-premises machine, virtual or physical, or your laptop could be talking to this. This is always talking over a network, whether it's public internet or whether it's that AWS's internal network. So just keep that in mind. So it's not like, oh, well, why would I ever use S3 when this is faster? Well, S3 is a fundamentally different thing if you need storage. But just keep that in mind. So these three have to be attached directly to it. Works.
An instance of storage is literally the hard drive on that EC2 instance.
Exactly. On that physical host, it is on the system bus, as opposed to EBS, which you never have to think about it or worry about it because it's all happening automatically in the background. it is technically network attached to the hosts. Which is why if you stop your instance and start a new instance, or like you start it and stop and start, power off, power on. It's gonna start on a different host, but it doesn't matter because EBS is network attached, and you don't have to reattach it, just is how it works. Yeah, but instance store is ephemeral, we spell it ephemeral, because if you stop your instance and start it again, it's not on the same host, so anything that was on that local bus is not there. And when you're looking at EC2 instances, and you do need something with ridiculously low latency, instance store is very nice, but there's no additional charge, just instance types that have instance store, it's just part of it. You can't add it to instance types that do not provide instance store, it's not something you can add.
You said something earlier that from Amazon EFS above, these ones are all file system.
These are classes. FSX and EFS.
So how does that compare with the EBS or the InstaStore?
These are directly attached to only one EC2. So it's like, basically, think of it as the hard drive in your laptop. It cannot be separated from. And it can't really be shared unless you use like file system software to turn your EC2 instance into a file server. This is where the operating system lives. This is where your applications. These are just file systems, meaning, all right, well, I have an EC2 instance, but I want to store bulk data and share it with other EC2 instances or with other clients in general. Then you're looking at FSX.
So if you move an object from an S3 standard infrequent access to EFS or EBS, is it a clone? Or is it like moving it to an EC2 instance?
Yeah, you're just copying.
Okay.
Yeah, because you can't mount an S3 bucket because it's not a file system, it's an object store. So any operations, you would do a get operation, which would download it to, whatever storage system, whether directly to the root volume or attached EBS volume to your EC2 instance, or using an EC2 instance or some other client downloading it from S3 to EFS or FSX.
And files in EBS be downloaded?
It depends on the operating system.
Okay.
I mean, it doesn't really matter. It would be EBS, think of it as nothing more than it's the hard drive attached to the machine. It's just all virtual. Yeah, so like, to download something from your laptop, your operating system would have to provide it, a way to do that. So on your EC2 instance, if you wanted to download something from EBS, the EBS volume on the EC2 instance, you would have to provide a way to do that software. Well, S3 is like I said, very different in that it essentially has a web server in front of it that's invisible. You don't see. You do a get operation on it, an API call, and that lets you down.
Does it make sense to ask a corresponding question about latency between two VMs, two EC2 instances?
Yeah, so if they're in the same availability zone, it is ridiculous. It's single digit on the second.
Millisecond, but not microsecond.
Not micros. And even between AZs, we say it's about 3 milliseconds. So if you're doing super high performance compute, there are things you can do called affinity groups. There's other things you do to basically make sure your EC2 instances are physically close. If you're at that kind of cutting edge stuff.
Yeah, that's where I was headed with the question.
Yep, you can do that. You can take, these are all physically in racks next to each other. So if you need high performance compute, you need a file system, then FSX for Lustre and OpenZFS are very fast. We have other file system services. They're more, I don't know why they're not listed here, EFS is closer. These are built.
Can you speak to the cost difference between that and an S3 bucket? So if I don't need a file system, I need storage for like one speed. Is that?
Yeah, so S3 is always going to be less expensive for data storage. Just, it will always be. Because it's different than, right? If you just need to store data and when you do need to access it, you can do it in a manner befitting S3 versus it has to be a mounted NFS share, then S3 absolutely. If it's like, this has to be accessible as a file system, because either my application or the humans using this data can't work with S3, then look at it. If you're big,
So I get almost my question. Let's say I don't need a file system, but I want faster write access. Is EFS still my, no?
not necessarily.
I understand.
If you're doing it from on-prem, that's almost entirely at your way anyway. You can.
Right.
Right. You can write to S3 from an EC2 instance very, very quickly. And it's honestly more dependent on the EC2 instance type than anything to do with this. So we have customers who are doing like thousands of transactions per second, tens of thousands of transactions per second on that platform. All the time. So.
Yeah.
Okay. But I would love to dive deep. So if my day job is covering UW, but I'm also a storage specialist. So yeah, I would be happy to talk about it.
Maybe worth, yeah, because I was working on a project where the write speed to S3 from an EC2 instance from actually from a batch nodes, like AWS batch, which are EC2 instances, right?
Yeah.
Was not as fast as we were hoping, but that may require a deep dive.
Yeah, I would need to look at all the parameters around it, because you can scale up to ridiculously fast parts to S3, but it's very dependent on. Yeah, this is more EFS archive storage class. So you can even lifecycle it. Long-lived cold data in EFS, you keep it there so that I can offload S3. Oh, and infrequent access storage class is also being reduced by 36%. Now, note that the request cost is higher to get it out of archive. So you can't like try and cheat the system by saying I'm gonna put everything in archive, even though I use it all the time, because it's 3 times the cost, the request cost. So if it's truly stuff I'm not gonna touch, then it's absolutely worth it. If it's, I'm gonna touch this way more than I thought, or I thought I was gonna save money by doing this, you gotta keep in mind it's 3 times the price for the request price. Amazon Q. So we launched Amazon Q this year. It's available in the spectrum of AWS tools and services. Amazon Connect and AWS Supply Chain and Q offerings. Amazon Q Business. It's our generative AI powered assistant designed to work. That can be designed for work that can be tailored to your business. It's all the stuff it does. It's also, if you look at our documentation, it's that little purple hexagon in the lower right-hand corner. It's modern AI clippy. This is Amazon Q business interface. I thought I actually had hidden some of these slides because this is specifically for commercial applications. That's good. Q for QuickSight. We ever use QuickSight as our BI tool, kind of like Tableau Lite. Good integration with that. Yeah, this is our expert interface for Q. So, like I said, there, President AWS documentation. Code Whisperer is our AI powered tool for looking at your code and saying, hey, I think this is could be done better, or This is going to create an error later on. Q is now basically the Q engine is integrated with Code Whisperer. Now, Q generative SQL for Amazon Redshift Query Editor. This is admittedly pretty cool. So it makes it a little easier to write queries for Redshift. Also, you can use Q to look at BBC flow logs and CloudTrail and CloudWatch logs, which will help write like Athena queries for you. So if you're not a SQL expert, it can help you translate what you're trying to do. So look at CloudWatch logs, which is great. So I looks like I'm way over time, so I'm going to go through. You don't care about Q and supply chain management. I wouldn't guess that'd be a different department here at the university. SageMaker is our machine learning and AI studio. It does a bunch of different things for machine learning. This is the Clarify FM evaluations. And we're honestly adding stuff to SageMaker all the time. So if you like SageMaker, just keep an eye on the blog. There's always new stuff. We don't wait for ReInvent. So smart sifting, which is automatically inspects training data on the fly to selectively learn from only the most informative data samples. Low loss samples, those that are already well predicted by the model, are discarded because they have less impact on model learning. So this allows model training to focus on sample data that has relatively high loss, which is what the model needs to keep learning against. So this reduces model training time by focusing on the most impactful training data and only costs up to 35%. So new capabilities in SageMaker allow customers to deploy multiple models to the same instance to better utilize underlying accelerators. So this abstracts your ML model and enables you to assign CPUs, GPUs, or neuron accelerators and scaling policies per model. And SageMaker will intelligently place each model across instances behind the endpoint to maximize utilization and reduce costs. So each model can be independently scaled up or down to 0, freeing up hardware resources for other models to make use of the accelerators. Each model emits its own metrics and logs, and a new least outstanding requests routing algorithm leads to more even distribution of requests, resulting less end-to-end latency. So effectively achieving a reduction in model deployment costs by 50% on average, with 20% lower inference latency on average. I'm noticing I'm way over time here, but I'm going to keep going. Hyperpod, training a foundation model is challenging due to large amounts of data. To reduce the amount of time distributed training is used with its own complexities, cluster hardware, model training, distribution code, model inspection. All of this requires deep ML expertise. SageMaker Hyperpod streamlines distributed model training by effectively distributing the training activity across thousands of accelerators in the cluster, processing them in parallel. So Hyperpod's training cluster is resilient and self-healing and allows you to iteratively pause, inspect, and optimize model training for frequent checkpoints, saving up to 40% training time for foundation models. Code Whisperer Custom. Code Whisperer Custom allows you to train Code Whisperer on your existing code bases to learn these internal practices, significantly accelerating development. Your developers will receive code recommendations that are aligned with your best practices, use your APIs consistently with the rest of your code base, and follow established patterns. So Code Whisperer support for languages and AI-powered remediation. Code Whisperer now supports infrastructure as code like AWS CloudFormation, AWS CDK, HashiCorp Terraform. So this will tailor your application codes, or currently supporting Java, Python, JavaScript, to remediate identified vulnerabilities. Amazon Bedrock. So, as a fully managed serverless service, you don't need to worry about complexities of training, posting, or scaling LLMs, but instead you can focus on using generative AI in creative ways to enhance your customers' experience, boost employee productivity, create content, and improve business processes. As a serverless API, you can make real-time synchronous requests, streaming response requests, and newly launched ReInvent batch inference requests. So, foundational model in Bedrock. Here, I'll read them all out. Read them. And break while you're doing that.
Bedrock, is that basically an inference service versus SageMaker is more of a training kind of development platform?
Yes. Yeah, SageMaker, you have way more control over it. This is just for you. You're building your own model.
Yeah.
You can use, of course, tools and everything. While Bedrock is basically, I want to make an API call and let somebody else do whatever it is.
Basically hosted models, like
Yeah.
pre-trained models.
When we feed data into Bedrock, are we also training those models as
These
well?
foundation models have been trained on a large corpus of material. That training content doesn't include your organization's private data, business context, and terminology. So, that's an important piece. While you can use Bedrock, Bedrock is not using your data. Foundation models of Bedrock can be customized through a technique called fine tuning, which allows you to point to example data that you have labeled and tailor the model for your content. So fine tuning is available for Llama 2, Cohere Command, Titan Text, Light, and Express, Titan Multimodal Embeddings, and Titan Image Generator. Fine tuning for Anthropic Claude models is coming soon. Pre-training is a similar technique that uses unlabeled data to supplement your foundation model with additional knowledge about your domain or industries. Pre-training is available for Titan Text FFX. So with both fine-tuning and pre-training, Bedrock makes a separate copy of the base FM that is private to you. Your data is not used to train the original base models. So organizations that have private data they want to leverage or have an internal corpus of documents and terminology, this is why you might use it. So selecting the correct model is important to get the best output for your use case. Model evaluation for Bedrock helps you select the right foundation model for your task, helping you measure the trade-offs between accuracy, latency, and cost when selecting. Knowledge bases for Bedrock drastically simplifies common scenario of using company data in LLM applications. With knowledge bases, you don't need to learn additional tools such as LangChain to build retrieval augmented generation solutions using Bedrock. Though this release includes a retrieval plugin for customers that want to use LangChain to orchestrate their workflows. So point your knowledge base at your data in S3. Bedrock will manage the ingestion workflow into the vector database, and you can use the retrieve and generate Bedrock APIs to retrieve relevant data and perform LLM generation on that data. Agents for Bedrock allow your Gen AI applications to take action on your data and systems using automated reasoning based on user direction and a library of available data sources and actions. So you enable Bedrock to access your data as well as perform API actions on your system. and allow Bedrock to reason about what data it requires to perform the requested action. Bedrock agents breaks down and orchestrate tasks, securely accesses and retrieves company data for retrieval augmented generation, and takes action by invoking the API calls. Gen AI applications are often very broad in nature, allowing for a variety of user interactions and generated content. It's this broad nature and generative capability that makes Gen AI so interesting. So with this flexibility comes inherent risks, both in user input and in generating output. The guardrails for Bedrock allows you to put safeguards in place to ensure interactions are within guidelines and used responsibly. Organizations can put policies in place to filter out toxic language or other harmful content. Topics can be restricted to avoid use cases that should not be allowed. And soon you'll be able to redact personally identifiable information. For example, when summarizing customer content. Step functions for Bedrock. Step functions are it's a state machine. You can now integrate Bedrock as part of your step. Does anyone use step functions? Okay, sure. One of my favorite examples of step functions is it's a little more than like an event rate or event bus, in that there was a DMV somewhere that has like a 1 year wait, and then a human has to do something before the step function will continue, and it can still orchestrate. Like you can put in a pause of a year in your step function, which I thought was very interesting. Clean rooms, ML. So organizations that want to securely share data with business partners and form ML on top of shared data. AWS Clean Rooms ML helps you and your partners apply privacy enhancing machine learning to generate predictive insights without having to share raw data with each other. The Clean Room ML's first model is specialized to help companies create lookalike segments. You can train your own custom model using your data and invite your partners to bring a small sample of their records to collaboration to generate an expanded set of similar records while protecting you and your partner's underlying data. Healthcare modeling will be available in the coming months. You retain full control and ownership of your trained models, including when to use them to generate lookalike segments with your partners. Your data is only used to train your model and never for AWS model training. Okay. I'm going to go through this. I don't know why I didn't hide these slides. I mean, this is fun, but mostly relevant. Yeah. Step function HTTPS endpoints is also fun, but mostly relevant. Networking security, IAM, Identity Center, Trusted Token issuers. So same technology that powers S3 access grants. IAM, Identity Center administrators establish trust to the external identity authority, so trusted token issuer, and may attribute between identities. So applications are associated with trusted identity providers by the Identity Center administrator. So you can basically give out IAM tokens based on. GuardDuty, runtime monitoring. GuardDuty is machine learning powered security service that is looking for weird stuff going on, like in your AWS account. If it's somebody is now launching an EC2 instance type that you've never launched in a region you've never used. I'm going to tell you about. But GuardDuty, everyone should turn on GuardDuty in your accounts, please. So runtime monitoring. So threat detection is currently available for existing vulnerabilities, but not for the actions taken by your EC2 instance or ECS tasks. What we mean by that is like the AWS API calls, the calls you make to AWS to do something. GuardDuty can monitor. They can't monitor what your EC2 instance is doing inside. So if you want to detect malicious IP connections associated with cryptocurrency, Tor networking, or CNC traffic, utilize GuardDuty runtime monitoring. That's pretty cool. Amazon Inspector for CI/CD container inspection. The inspector can now be invoked to scan container images for security issues from third-party CI/CD tools via ready-to-use plugins for Jenkins and JetBrains Team City with more to come. So this works with CI/CD tools hosted in AWS, on premises or hybrid clouds. There's also a new API, Inspector Scan and Command Inspector, available in your AWS SDKs and AWS command line interface. Allow you to integrate Amazon Inspector with the CI/CD tool of your choice. Access Analyzer, this one is cool. So this simplifies inspecting unused access to guide you toward least privilege by continuously analyzing your accounts to identify unsecured access and displaying all findings in a centralized tab. Basically, Access Analyzer is saying it's going to have a visual dashboard that say, okay, every IAM user in your account, you have given them full access to everything. Maybe don't do that. Things like that. And different other findings. It's like, okay, well, this person has these resources, access to these resources, but they're doing something with these other resources. Things like that. So this is really cool. Check out. I set up, and this happens constantly. I set up IAM access for a student in my lab, and they have since graduated. Yet they still have active credentials to log into my AWS account. This is like a centralized place to show you. Not that has ever happened in academia, ever. Custom policy checks, what it says on the label. Checking new actions, say, oh, wait, you've given SSM access. Let's do something a little more precise. So it's going to check policy. Someone's written a policy in your account. It's going to say, oh, wait, back off. This doesn't meet this doesn't meet my specifications that I set for my environment. Lambda code scanning using Inspector, powered by, of course, GenAI. So you can then inspect your Lambda packages. Weakness encryption, like it says there. Injection risks. Comments like, oh yeah, if you do this, you're vulnerable to this kind of very common vulnerability. Detect finding group summaries. I don't know that anyone is using the detector you have. There's new features for detective. I'll just kind of zoom past that. Route 53 application recovery controller zonal auto shift. Well, very cool. It's probably not super relevant for most researchers, but if you are a networking person, then yes. This is application load balancer, security and resilience. So our application load balancers now provide two different options for performing mutual TLS with X509 client certificates. One, pass-through mode, which will send the entire client certificate chain to the target using HTTP headers, enabling you to implement relevant authentication and authorization logic in your application. Or two, verify mode, which offloads the client certificate authentication to the ALB when negotiating TLS connection. You can use AWS private certificate authority as well as any third-party certificate authority along with optional revocation checks. Two modes for doing TLS off certs. Once again, really cool networking stuff, may not be super relevant. Yeah, this is those, I probably shouldn't say it, especially those weird hand scanners. Where it's looking at your palm and like the veins in your palm to identify you. You can now like buy these and use them in your institution. So, yeah, if you've ever been to like a Go store or some other retailer that's escaping me now, you can pay with just your palm. So, oh, I know, and you have a payment method attached. So you can now use them in your own. Yes. CloudWatch application operations. So it's hard to monitor EKS, which are Elastic Kubernetes service based and or distributed applications. So signals make it easier for teams and application operations to automate the configuration of these systems. So, targeted for EKS apps, basically just a way to get different information in cloud launch.
Need to go, thank you.
Yeah. This one, is cool, and I'll probably wrap it up after this. But console to code, this is in preview. This is something that people have been asking for since essentially, the dawn of the universe. Is a way to create a confirmation template from an existing architecture. So I have launched a whole bunch of stuff in my AWS account. And I want to make a confirmation template from it, not the other way around. I don't have a confirmation template yet. This is console to code, this is a preview. That is going to do that. We have attempted this before. It has not always gone that well. We're doing it with enhanced AI capabilities now to create a confirmation or CDK template from your existing, which I think is cool. It is a preview. I will let everyone know once. Oh, yeah, CloudWatch logs and frequent access, that's cool. So if you push logs, CloudWatch logs, you can make it cheaper. And there's been some enhancements to billing and billing management console. I won't go through them, just know that if it looks different, it's because we're trying to make it better. Cost optimization hub, same thing. And cost and usage dashboard has really come a long way. So lots of new developments there on your cost and usage. And that is it. So that was absolutely ridiculous amount of information in a very short amount of time. Much of it probably did not sound like any actual English words because it's all acronyms, but you have the recording. I will send out the slide deck and please ask questions about it if you want any follow-ups. Oh, somebody's answered my question, but I was just looking to check. So I will stop the share. Do we have any questions in the room or online of anything that went on? Or just in general, doesn't have to be the avalanche of new features that I just talked about. Seeing anybody?
Nothing online.
Okay,
So it sounds great. So thank you very much. Really appreciate the avalanche.
That was heroic, Joel. Thank you.